In this movie, we will learn to draw a graph from a data table and then to draw a best fit line through that data. Here's our problem. A car travels on a road. Its position x is recorded in meters as a function of time t in seconds. We are asked to plot the data and then to draw the best fit line to the data. Here is a table that shows the position versus time data. We will draw the graph with time, which is the independent variable on the horizontal axis, and position, which is the dependent variable on the vertical axis. Our first job is to choose a scale that we will use for the axis. Let's first choose the scale for the time axis. We first find the range of values for the time axis by subtracting the smallest number from the largest number, which gives us 1.0 minus 0.1 seconds, giving us a range of 0.9 seconds. We then divide this range by 5, which gives us 0.9 divided by 5 equals 0.18 seconds. We round the value of 0.18 seconds to the nearest convenient counting number, which is 1, 2, or 5, or multiples of those numbers. When we round 0.18 seconds, we get 0.2 seconds. This number of 0.2 seconds will be the interval for the scale. If our lowest value on the horizontal axis is 0.0, the other values will be 0.2, 0.4, 0.6, 0.8, and 1.0 seconds. Namely, we mark the scale at intervals of 0.2 seconds. Notice that we started the scale at 0, and this makes sense if the data itself starts close to 0. Our markings on the horizontal axis of the graph then will look like this. To choose the scale for the vertical axis, which is the position, we do a similar thing. We take the range of values for position, which is 24, which is the largest value, minus 4, which is 20 meters. We divide this range by 5, which gives us 4 meters. We round 4 meters to the nearest convenient counting number. This rounding gives us 5 meters for the intervals, which means that our vertical scale can be 0, 5, 10, 15, 20, and 25 meters. And this is how the scale on the vertical axis is marked. Here are some of the common errors that are made in choosing scales. In this case, the horizontal axis has too many markings, which is not necessary. In this case, the vertical axis has too many markings, which makes it very crowded and hard to read. In this graph, both axes have too few markings. This would make it hard to plot data. Thus, balanced spacing of markings on both axes makes it easier to plot the data without making mistakes. Let us now go ahead and plot the data on this graph. Our first data is at time 0.1 seconds and 4 meters. The second data point is at 0.2 seconds and 7.1 meters. The third at t equals 0.3 seconds and 9.7 meters, and so on up through the graph until we plot all the data in the table. We notice that there is some scatter in the data. But this data appears to be linear, which means that the best fit is a straight line through the data points. This is how we draw the best fit line. The line has about as many points above it as below it. That line may not go through the origin, which is t equals 0, x equals 0. It may not go through all the data points. In fact, if the points have a lot of scatter, it may not go through any of the data points. And yet, it is the best description of the data. So the best fit line then is a way of averaging or smoothing the data. Individual data points have errors due to the limited accuracy of the tools used for measurement. You might ask, isn't it more accurate to just join all the data points? Drawing lines that join one data point to the next implies that the measurement is so accurate that there is no scatter in the values. The scatter in the data points is due to errors in the measurement, and therefore the data is best described by a smooth line. Joining points makes sense when you have data that does not follow a smooth pattern, such as the daily high temperature or the price of a stock. But when an object such as a car moves at an almost constant speed, it makes much more sense for us to draw a best fit curve or a best fit line that describes the motion of the object. If you were to draw this same data by hand, this is what it might look like. The best fit line is drawn in a similar fashion.